Hello, my name is Caitlin Williams, and I am an environmental health researcher. And today I will be speaking to you about gene environment interactions. Disclaimer: this is a student presentation using a hypothetical scenario for educational purposes. The presenter is a student at UAMS, not a representative of the agency named in the following slides. The information contained herein does not necessarily reflect the views of said agency. On the slide before you are 3 points that should be included within my final presentation, which are: what are gene environment interactions, asthma as a gene environment interaction disease, and implications for public health and prevention. What are gene environment interactions? Gene environment interactions happen when the effect of environmental exposures on health depends on a person's genetic makeup or vice versa. It's no longer nature versus nurture anymore. It's more so nature and nurture combined. So when you think of gene environment interactions, I want you to think of your genes like a blueprint. But the environment, such things as air pollution, diet, stress, or allergens, can influence how that blueprint is read and expressed. Some genes may make a person more vulnerable to certain exposures, others may be protective of the individual from those exposures in the environment. Now I'm going to delve deeper into asthma as a gene environment interaction disease. Asthma is a chronic lung disease that affects over 300 million people worldwide. Some may even say nationwide. It's a ideal example of a disease shaped by both genetics and environmental interactions. Genetically, certain variants affect how our immune system responds to allergens or irritants, but genetics alone can't explain the rise in asthma cases over recent decades. That's where the environment comes in. Factors like air pollution, secondhand smoke, allergens, and even urbanization play a major role in the rising numbers of individuals having asthma. It's the interaction of susceptible genes and harmful environments that increases the risk for asthma, not one or the other alone. Now I will break down the genes involved in asthma. Research has identified multiple genes linked to asthma, including ORMDL3, IL4, IL13, and ADAM33. These genes are mainly involved in inflammation, airway remodeling, and immune regulation of the body. But importantly, having these genes doesn't guarantee that an individual will develop asthma or not. It depends on when and how environmental exposures happen, more so in childhood, when the lungs and immune system are still developing. Listed below are some environmental triggers for asthma. Common asthma and triggers include air pollution, allergens, tobacco smoke, viral infections, and even occupational exposures. Now, when it comes to air pollution, we're discussing like ozone and particulate matter. When it comes to allergens, that breaks down to dust mites, pet dander, or mold. When we talk about tobacco smoke, we're talking specifically in homes, which is in a closed area. When we discuss the viral infections, we're talking about during early childhood. And when it comes to occupational exposures, we're talking about occupations such as farming and or cleaning. And when these exposures happen to someone with asthma susceptible genes, the risk skyrockets versus an individual who doesn't have asthma susceptible genes. And let's not forget, timing does matter. A child exposed to smoke early in life may have a very different outcome compared to a child who isn't exposed early in life but later. I'm going to provide a real world example to break it down and make it more understandable. So, there's a gene that is called GSTP1, which helps the body detoxify pollutants that enter the body. Some people have a variation or mutation of that gene that reduces the body's ability to detoxify the pollutants that enter. There are some studies that show that children who have this variant, who are exposed to traffic pollution, are more likely to develop asthma than kids who don't have the variant. This kind of data helps explain why some kids living in the same neighborhood get asthma and others just don't. It's not just environmental triggers that cause individuals to get asthma, it's also the person's genetic factors. Now I will discuss the implications for public health and prevention. So, first, it means that the one size fits all prevention strategies that we are using now may not be enough. We need to implement targeted interventions that account for both genetic and environmental risk factors. Second, it means that we can identify high risk groups using genetic screening. Through the genetic screening, it does come with ethical concerns like privacy and access to those. And third, it reinforces the importance of reducing harmful exposures for everyone, especially children. So, with that being said, cleaner air, smoke free homes, and better asthma education can make all the difference, regardless of a person's genetics. So, here I will break down the steps and where we are when it comes to us moving toward precision prevention. The future of public health may lie in precision prevention, just like how we talk about precision medicine. So, I want you to imagine being able to tailor asthma prevention programs based on a person's genes, environment, and their stage in life. No, we're not there quite yet, but with the advances that we are making in genomics, exposomics, and data science, we're getting closer day by day. This could help reduce asthma rates, especially in vulnerable communities, exposed to both genetic and environmental burdens. So, as I get ready to near the end of my presentation to you all today, there are a few key points that I want you to remember. And those are gene environment interactions help explain why diseases like asthma develop in some people but not others. Asthma is influenced by both genetic factors like immune system genes and environmental exposures like air pollution and allergens. So, I want you to know understanding these interactions can help us design better public health interventions and move toward personalized prevention strategies. On the slide before you, I would like to leave these references with you in case you would like to delve deeper into the information that I presented in my presentation on gene environment interactions and specifically asthma as a gene environmental interaction disease. Thank you.